So we left off, I think, looking at some of these different methods for how to modify lists, like reversing and sorting and things like that, if I remember correctly. And now we're going to talk just briefly about how to make different data types work together, because we've seen these different data types, and I think we even saw an example in lesson 1, if you try to sort of add a number and a character string together, of getting some kind of type error message that tells you that basically Python doesn't know what you're trying to do when you say take some number plus some character string. So let's continue from here with just a little bit about how to make these different data types kind of play nicely together. So if we just check our types of a couple different variables here, we had station underscore name. And its type, of course, is a character string. Makes sense because it's going to be some kind of text name. We had our station ID, and that was a type integer. Remember, it was a whole number value. And our station latitude, which we could look here as station underscore lat. And that's a floating point number because it's a decimal value. 60.15 or something like that, I think, was what we had. So if we try to add our station name and station ID together, we do station name. Station name plus station underscore ID. Here we're going to get that aforementioned type error, because Python basically is like, what are you trying to do? You told me to add a sort of string of numbers, or a string to numbers, and it says, well, I can't do that. I don't know what you want me to do, but I can only concatenate string to string. So if you took two character strings together and plus them, it will just add them together as a single string, but it says I don't know how to do that with an integer, and that's what this error message is indicating. So we have a problem, in a sense, because it's actually a pretty common thing you might like to do, for instance, to print out, the station name, and then maybe the value of your station name variable has station ID, and then perhaps the station ID number. So if we want to get those things to play nicely together, we need to convert the data type. And we can do that for our station ID using a function called str, which is just to do a string conversion. So if we had our station ID underscore str, we'll make a new variable. And in there, we'll use the str function to convert our station ID from a number to a character string. This is one way in which we can do this. And so we'll make our new variable station ID underscore str, and then we'll use the str function to convert a number to a character string. And we can check its type as station ID underscore str. And sure enough, its character type is string. And if we just look at the value we have in there, station ID str, we can also see just by printing out that value that it is the same number we had before, but now wrapped in single quotation marks, which again indicates that this is a character string and not a numerical value anymore. So that's good, because that means now we can perhaps make it play nicely with our station name. But if we try to do math with this, obviously we may encounter some problems. But there's functions to do these kind of type conversions for standard data types. So there's str to convert to a character string. Int will convert a number to an integer. And float will do the same kind of thing, converting a number to being floating point. So those are some additional options. And now we have a couple poll questions here, so let me make those visible real quick. I'll make both questions 3 and 4 visible, so we should be able to see now this. I don't know why it says pop here. But yeah, we have two questions. and make this maybe a little bit bigger. So you can select the output you would expect when you execute the following statement. So print station ID plus station lawn. So you can then choose from the 4 options that are here. And once you've done that, you can select the output you would expect when you do the following here, which is print station name plus station ID underscore str. So why don't you go and vote on those 2 options here, and then we'll continue in just a moment. So we got lots of different choices here. One that seems to be leading the way is that we'd get a type error when we print station ID plus station lawn. And so, why don't we find out? So let's just jump back here for a second. I'm going to add a cell here. And if we were to print out station ID plus station lawn, was it? I think. Station ID plus station lawn. Let's run it and see what do we get. Aha. So we get a number. 132,334.96. So yes, as it turns out, instead of a type error here, because we're adding 2 things that are both numbers, it doesn't matter that one's an integer and one's a floating point number. Those are compatible. What's going to happen inside the kind of computer is that station ID will be converted automatically from an integer to a floating point number, and then the 2 values will be added together. So these are compatible data types. In earlier versions of Python, Python 2 point whatever, you had to be a little bit careful when doing math with integers and floating point numbers, because things like division operated kind of weirdly. But now what happens basically is, I think, what is somewhat logical, which is the station ID just gets treated like a number being added to another number, and what you get back is going to be, if it's 2 integers, you get an integer back. If it's one of the 2 is a floating point number, or both, then you get a floating point value that comes back. So that was our first question. Let's see what the results look like for question number 2. So when we add together station name plus station ID str, the suggestion would be that we'd get Helsinki Kaivopuisto 132310. And yes, I think that's going to be the case here. So let's just print that real quick. So station name plus station ID str, Helsinki Kaivopuisto, and then this. So what happens here is now, because station ID is a character string type, when you use the plus to do the mathematical sort of addition idea here, it just takes the 2 strings and concatenates them. Just adds the second one to follow immediately after the first, so there's no space or anything here. It's just the station name ends in the letter O, and station ID starts with the number 1, and it just continues on as if the 2 strings have been added together. So this concatenation thing is a common type of thing to do with character strings, just using the plus operation. It's kind of a handy way to put strings together. So yeah, we could do this thing about combining text and numbers as well. And I think I'll leave you to have a look at that on the course page just in the interest of time, but essentially you can do what we just did, which is to use the plus operator to make something like station name and ID by adding things together. We've basically just seen an example of how to do that, so let's go here to working with text. This is the last thing we'll cover in terms of our Python lesson for today, and then we really need to shift over to learning about version control a bit. But it's obviously pretty common, as you could imagine, to have things where you have numbers and character strings and you want to put them together, for instance, in print statements to kind of write things out to the screen as you're working. And there's a few different ways in which you can do this. So the kind of common approaches in Python are basically these 3. So I think since Python 3.6, or maybe even before that, F strings have been the thing. F strings are super cool, and that's what we're going to learn, because this is definitely the way to go for how to combine and format text and numbers together. But we also show an example of how to use the .format method, which is something that's a little bit older style of doing things. It's kind of looks a little bit like an F string, but it's more clumsy. And then the percent operator is like the old school way to do this in Python. These are kind of here basically just because you may see code that uses this approach and might want to kind of understand how it works. But this is not, neither one of the number 2 or number 3 would be things we'd recommend that you take into practice. So let's talk about F strings for just a second here. So if we had some variable here called temp, and it could be used to store, for instance, a temperature with a bunch of decimal places. So you can just run this cell here. And if you wanted to take a look and print out, for instance, some information about the station name and the station ID and some other things that could go along with that, we could, for instance, do something like this, which is to do the print statement. And then we're going to do something that might look a little bit weird, which is to put an F in front of some quotation marks. And the F in front of the quotation marks is the way they indicate that you're going to use what's called an F string. Then we're going to put some text inside there. So we could say the temperature at, and then we'll put some curly brackets here. So for those using Finnish keyboards, I hope you sort of know how to make a curly bracket. It's kind of hidden, so at least for me on the Mac, it's like Option Shift and then the 8 and 9 for the parentheses. So hopefully it's something similar, maybe like Alt Shift if you're using a Windows machine, but you'll make curly braces there, and then what we're going to put in here, so the temperature at, and we'll put a variable name inside the curly brackets here. So temperature at station name, and then outside of the curly brackets we can say station, and then we could perhaps add, for instance, parentheses here. So this is just for our kind of formatting. We're going to put another set of curly braces here and put the station ID. And then we can say is, and yet another set of curly braces with temp, and then colon point to F, and I'll explain kind of what this does in just a second. Celsius. So we have this print statement. Everything that's in quotation marks here and shows up in red is going to be printed as like normal character string text. The stuff that shows up in black is someplace where you're going to substitute in the value of some variable inside this string. So the temperature at station name station, so we're expecting this to be replaced with some text. ID is then going to be in parentheses after that with the station ID, and then is, and then here again we're going to substitute in our temperature. But there's a little extra stuff here, and this extra stuff comes after the colon, which is that there's a point 2 and then the letter F. What this indicates is that we're going to display this as a decimal value with 2 decimal places, and the F indicates we want to display it as like a normal floating point number, so not like use scientific notation or some other kind of formatting, but point 2F will basically round this to be 2 decimal places in terms of the precision of the number that's shown. So if we run this, what you see is that the temperature at Helsinki Kaivopuisto, so that's substituting in for station name, ID, and then here's the station ID, is 18.57 Celsius. So you notice here that the 0.567 blah, blah, blah gets rounded to 0.57. So it takes care of rounding for us. It does not truncate the number at 2 decimal places, but rounds it nicely to that desired level of precision. So you'll see more examples of F strings in the exercises. You get a chance to work with them a little bit. But the basic idea is that it starts with the letter F and then some quotation marks, hence the name F string, because quotation marks are used to indicate a string. And then inside there, you can use curly braces to basically substitute in values from different variables. And in this way, you can very flexibly decide how you want to have your things like numbers represented. So if we did point to E instead of point to F, if I'm not mistaken, point to E is the way that you indicate you want to use scientific notation. For temperature, it probably doesn't make a lot of sense to use scientific notation to represent it, but if you were, doing things like the age of the universe in seconds, most probably you're going to want to display that number with scientific notation. So, this will depend a little bit on the sort of use case that you have. But there's actually quite a bit of different things you can do with formatting your numbers. Of course, we could also have like 0.4 F or even 0.0 F, which would just round it to an even 19 with no value after the decimal place. So you're free to kind of modify this as you like, and depending on the data type that you're looking at. Most of the time, if I do any kind of formatting, it's because I have floating point numbers and I want them to look nice, because sometimes when you do math with Python, even though you divide something, it seems like it should divide evenly. You'll get round off and might have your number be like 0.00000001 instead of rounding off evenly to be 0.0. So that's where it can be nice to specify the precision you want to display, and it also just visually looks a little bit nicer. So that's our F string example. And you can find a little bit more information here about some of the kind of common ways you can format the numbers. So like here's the F for decimal number, E for scientific notation, percent sign. We'll convert the number to a percentage. So I guess if we wanted to do 0.2%, then we can see that we get 1856.79 Celsius, which again probably doesn't make a lot of sense to represent our number like that. But there's some other details here in the text on both the web page and in the notebook that describes how this works. And then there's also an example that shows how to do this with the .format approach, which is somewhat, again, similar to an F string, but different enough that I think F strings are much faster to use. And then the percent approach is, again, it's a little bit less intuitive, I would say. So if you want to find more information, you can take a look at some other linked pages here. But I think for right now, that's kind of where we'll leave things. And yeah, I'd ask, do you have any questions at this point before we shift over from our Python lesson to doing some things about version control? Okay. So let's go here to the course page, make it a tiny bit bigger, and our lesson overview. Yeah, we've covered our basic Python stuff for today, which is our basic elements of Python, and now we're into our introduction to version control. And I hope we've got time to get through this. I think at least we have time to get through the important part, which is that information you need to know to be able to to work on the exercise for this week. So let's jump in here. So version control perhaps is something by itself that doesn't necessarily mean a whole lot to you in terms of a name, but I think experiences like this might look somewhat familiar. At least I'm sort of ashamed to show, for instance, my desktop of my computer, because it looks a lot like this. Even though I use version control, I still have a bunch of files and things that are not sorted nicely on my computer. So there's things like this, And there's also the experience you probably have when you deal with people like me with things like a bachelor's thesis or master's thesis or whatever, and that is that you finish it and you name it final.doc, and then it shows up on my desk or in my email box, and I do nasty things to it and send it back to you to make final rev2.doc, and then you give it to me again, and it's final rev.6.comments.doc, and I send it back to you again with more red text on it, and all of this sort of cycle repeats to the point that you end up with 15 different versions of something that you thought was done, and you're slowly going crazy. Part of the reason for using version control is for handling exactly situations like this, and that is that documents, whether they're software or whether they're things you've written, change through time. And as you make changes to those documents, it's not necessarily that you want to call the document something different. It might be your bachelor's thesis, no matter how many changes you make to it. So you might like to refer to it with that same name, but then keeping track of what changed between each one of the iterations you make when you share it with whoever's giving you comments. And the new version, typically what we would do is we'd save it as a new file name, and this gets kind of painful after a while. So the goal here is to avoid situations like this altogether. This is especially important in dealing with things like software. And so that's where version control comes in, is essentially a way to allow us to replicate the same desired thing, which is to keep track of changes we have made without having to save things as different file names. So version control basically, as a general concept, is used to track and store changes in your files without losing the history of the past changes. I think even last week I alluded to the idea that sometimes you're working on something and you keep working on an exercise and you suddenly break it, and so the code that you had that worked before no longer works, and one thing you can do typically with a version control system is to be able to go back to the point when the code worked and then figure out what you changed that ended up breaking things. The overall concept looks something like what's shown here in this diagram, and maybe I'll just again make this a little bit bigger. And that is that you have some some starting document that looks like this. Could be text, could be code, whatever. You make some change, which is meant to be shown as like a line. Maybe you wrote a new sentence, and that new sentence goes into the document like this. What the version control software is going to do is keep track of basically, here's what things started with as, here's what things look like after the fact, and the version control just keeps track of what changed between the versions. So that when you add 3 more sentences here, essentially each time you save a change, the version control software is going to keep track of what's different from the last time that you had saved one of your changes. So in this way, of course, by keeping track of what changes each time you save what you're working on, the version control software allows you to go back through kind of undoing the changes if you need to. So that's the kind of basic concept, and of course the reason that you might want to do something like this, related to the comics above, of course, is that it's nice to be able to keep track of the changes you've made in a systematic way. So without having this sort of messy whole list of different documents with things added to the end of the file name to keep track of it, you can keep track of the same file and just store the changes that have been made to that file and be able to easily see what you've changed through time. If something goes wrong, you can go back to an earlier version, etc., etc. And for version control software, I mean, there's many different systems that can be used. So I started out using something called Subversion. Subversion's okay, but then I've moved to Git, I don't know, probably more than 10 years ago, and Git is the sort of much better than Subversion for a number of reasons, and that's kind of part of the reason why we introduced that, is Git is probably the most popular version control system out there today. It's something that was developed, I think, maybe mentioned this last week, by Linus Torvalds, whose auditorium we're, again, sitting in today, also the creator of Linux, and yeah, it's something that really, since 2005, has become basically the standard in which people can keep track of changes to the software that they're working on or other kinds of files as you might like. basically just takes snapshots of the files of what's changed every time you save something. So if a new file is added, it will indicate that there's been a new file added. If you've modified something, changed some lines of your code, it knows what has changed when you save your changes, and it can even show you specifically what's different between two different versions, which is a handy thing to be able to do. So that's the kind of basic idea with Git, and GitHub is essentially just a way for people to work together using Git. So it's set up as a kind of web page to allow you to use Git, but to share what you're doing with multiple people. So yeah, it's kind of like the web, GitHub as a page is sort of a web-based interface to using Git. So you can store your software there. You can do all the kind of things you would normally do in Git through the GitHub page. But it's also more than that in the sense that you can collaborate with people. It's essentially like a social network of sorts. So you can invite people to work on your projects. You can share what you're doing. You can tag people. For bigger software projects, there can be tens to hundreds of people that are collaborating together and communicating about things like how to solve problems. There's a lot of elements of the GitHub page that allow you to interact with other people. It's also a nice thing from the perspective of open source software and from open science, in a sense, because it's possible to make your projects publicly visible on GitHub. So for instance, typically when I write some software that I want to share with people, I'll put it on GitHub and I'll include a link to the GitHub repository on some presentation I give or something like that, because I want people to be able to go there and check out the software. And by doing things that way, one of the kind of main ideas in open science is reproducibility, and you can make your work reproducible by providing a link where someone can go and get the software you've written and test it out themselves. So that's handy, as well as the possibility to create basic documentation on GitHub pages that can describe things about the code that you've written. So it might look a little bit weird the first time you go to some of these Git pages. The sort of information that you see here could be a little bit overwhelming with all these different kind of tab sections up at the top and things like this, but this readme.md file is probably the most common thing to find in a Git repository, and that's where documentation already right from the beginning can be given to sort of show you, like, what am I looking at? What is this thing all about? And here, then we've got some documentation explaining that this is exercise number 2, blah, blah, blah. If I was to look at another example of for instance, some other software that I had written, inside there's a little bit more stuff in here because this is a little bit larger project, but this is where I can already give some kind of basic information about what the code is. I can provide like buttons, like here, for instance, that someone could launch the code and test it out in Binder. Provide a DOI where the code is citable, for example, and also some basic information about how to get started using it, how to install it, and some basic things about using the code. So it's nice in the sense that it makes it easy for you to share both software and some information about how to use the software in one place. And of course, yeah, there are some other things in here, online tools that you can use for interacting with the software and with other users. Issue tracking, so if someone finds a problem in your code, they can go to your GitHub page and then open an issue where they say, here, I think I found a problem. For instance, last week when we were having the issue that Binder wasn't opening, Christoph had put an issue into our student notebooks GitHub repository saying that, hey, it looks like there's a problem with Binder. I'm just going to fix this for now, but he wanted to open the issue so that I was aware that he had made a change and the reason he had done that. So issue tracking is also maybe not something we'll use heavily in the course, but something you may want to be aware of. Okay, a couple terminology type things here. So I've mentioned the word repository already. That's what's used to refer to a collection of files that are part of a project in Git. It's stored in what's called a repository. It's sort of like the kind of archive of all the files, often referred to as a repo. So you'll already see the references to that in the course page. Each project would have its own repo. The word commit is basically the word that's used to say I'm going to store some changes that have been made to my code. So you have to actively tell Git that you want to commit the changes. It doesn't automatically save all of your little changes for you, but you have to yourself tell it, okay, I'm ready to save my changes. It's a good thing to do frequently. It's a tough habit to get into, but it's good to sort of like every time you finish one part of the problem in the exercise, there's no reason not to save that commit at that point, because who knows, you may break something later, and if you don't commit your changes, then of course Git doesn't know, and you can't necessarily go back and figure out what went wrong as easily that way. But yeah, to commit is basically just a sort of way to say you're going to save the changes. This can be used as both a verb and as a noun. So you can commit changes to your GitHub repository, or you can say my latest commit. So you'll see people using the word in both ways to refer to both the action of saving the changes and to some set of saved changes. Revision or version is basically just a saved set of changes at a given time. Cloning is the name for making a copy of a Git repository. So we'll do some cloning in just a couple minutes here to see how this works. And then there's pull and push, which are the words that are used in the sort of Git vocabulary to talk about copying changes down. So like when you take changes from GitHub to your local computer that you're working on, or to your instance in the CSC notebooks, you will pull the changes from the server down, and then when you push changes, it's basically copying from your local machine to wherever for instance, to GitHub from your local computer. And then hopefully we'll never have to deal with merges. But it is possible when two people have changed the same file at the same time, there is an operation called a merge that needs to happen where it tries to bring the changes both people have made together in some nice way. It's not always possible, and that's where I hope we don't have to deal with merges, because sometimes, if you Google Git merge hell or something like that, you'll find that this can become kind of a painful process when merging goes wrong. So it will happen to you at some point, and I'll give you my sympathies in advance, because it's not always nice to figure out how to get out of a merge that doesn't want to nicely work together. So that's the kind of general idea about version control. I'm going to jump here to the navigation just so we can go to our Meet Git part of the lesson. And this is where we're going to now start working with Git a little bit ourselves. And this is going to take us a couple steps to get things all ready to work. But by the end of this, we should be able to clone a repository from GitHub. That's a good thing. You'll do that each week for the exercises, so that's a nice thing to know how to do. We'll know how to add changes. We'll know how to commit those changes. So we'll see what the difference between adding changes and committing changes is. And we'll know how to push our changes to the GitHub page. We're going to use this Git plugin that's available in Jupyter Lab because it will make our lives easier. But we'll kind of go through here step by step. And because this is maybe a little bit, I don't know if I would say it's necessarily challenging to understand in terms of the concept, but it's a little bit of terminology that might be unfamiliar. I would say, we'll go through this stuff. I'm not going to spend a huge amount of time talking about exactly how things are working here, but it may be good to kind of take a look at the course page and read this through once more at some point before you work on the exercises this week, just to try to understand how everything is operating. So we have things like, in a picture like this, a remote repository, which would be your code on github.com, for example. So it could be a copy of your exercise on GitHub. You have your cloud computer you're working on in CSC notebooks, for example. And essentially what you want to be able to do is to get your code from GitHub to your CSC notebooks environment where you can make changes to the code, and then you want to be able to save it back up onto GitHub so that we can see what you've done and we can grade your exercises. That's the basic kind of overall workflow that we're looking at. So to get things from GitHub to your own computer or to the cloud instance that you're working with, we're going to need to be able to do this clone operation, which is essentially just to copy it from GitHub to your CSC notebooks platform. Then when you've made changes, we need to be able to commit the changes locally in the cloud computer and then push them to GitHub. That's the kind of loop that we're going to be working with. So things are going to need to be on GitHub so that the course instructors can look them over. But of course, you want to work on them on your own computer, because on GitHub you can view a notebook, but you can't actually interact with the notebook in GitHub. They would need to have their own kind of servers running for that purpose, and I guess that's probably not a great use of their resources. So when it comes to to making changes to the code, you'll be in your notebook like we have here. You'll change some code cell, you'll save it, and the first thing you're going to want to do is to indicate that you would like to save a modified file. And so there's an operation called adding that we'll see how to do that in just a moment, which basically says, like, I want to put some file in the list of things that will be saved as having changed. Once you have the list of files that you have ready for your change, you would then commit the changes, which would then store them as a new version, or store the changes as a snapshot in your repository. So in our cases, we're typically working with one notebook. So this difference between adding and committing might not seem like a big deal, but if you're working in a larger software project, you might have multiple things that you're working on at the same time. There could be tens or hundreds of different files that contain code. And so there, if you've made a certain change, you may want to add just a couple files out of the 100 that you've modified that relate to some important thing you've changed, and commit just those files and leave some of the other ones that you may have changed, but you're not ready to save the changes yet. You leave those kind of behind for a later time. But yeah, to get prepared here, I think we're already in the CSC notebook, so we don't need to worry about launching that. But what you do need to do is create a thing called a personal access token in GitHub. This is basically a way to... It's kind of like entering your password, but it's a little bit more flexible. The basic idea is that it's kind of a code that allows you to have a certain level of access to your files on GitHub. And it can then make sure that you could share or have someone creates an access token where they can read your files from your private repository, but they can't make changes or things like that. And in addition, this personal access token has a sort of expiration date. So it's not valid forever, which is a sort of security thing, just to make sure that these do expire, and they're easy to recreate, but it's basically there as a security thing in general. So in order to create one of these personal access tokens, you will need to go to the GitHub page and sign in. So for instance, if I just open a new tab with github.com, I would go here. I'm going to see a little bit different stuff than you see, but it looks something like this. And in order to create a personal access token, I'm going to need to go over to here to the right side where I'm signed in, and I think at that point need to go down to settings. So you'll go over on the top right, click on your user icon, again, assuming that you're signed in, and then go to settings. You can find, of course, instructions about this as well here on the course page. And maybe I'll just move this thing over. So within the settings, if you scroll down toward the bottom, you'll see there's an option down here called developer settings. It's at the very end of the list of things on the left side. So you're going to click on developer settings and then on personal access tokens. And I think as far as I'm aware, I should have no security risks in having all of this visible to you all and to anyone who sees things, because the idea with the personal access token is it's a secret thing. It gets created once when you make it. You can destroy it at any time, and it has a sort of a finite life. So I'll make one now, and I'm not going to worry that you all have my personal access token, because I'm also just going to delete it later. And as you'll see, it's not the kind of thing you're going to quickly type in while sitting here. So what we're going to do, if we just go back here, we're in developer settings, personal access tokens, and what we want to do is create a new token. So generate new token up here. And of course, I have to give it my authentication code because I'm using two-factor authentication. So perfect timing on that. But let's see, should be able to do that. Okay. So yeah, new personal access token, and let's give it a name. You can just call it whatever you like, but Geo-Python 2022 is not a bad name for your personal access token. So I'll jump back here. So imagine that for those who just signed into GitHub, for example, you're going to land on your kind of like starting page, and on the top right, you need to click on where you're like, I have my picture, but maybe you just have like, sort of some letter or something like that, and then go to settings. And once settings comes up, on the left side at the very bottom is developer settings, and you'll click that, and then personal access tokens is where you want to go from there. And then what we were doing is just to generate a new token. Okay, yeah, no problem. So again, we're going to give it some name. I'll call it Geo-Python 2022. Then what we want to do is set the expiration date. I would suggest not 30 days because that's not going to get all the way through the course even. But perhaps you can click custom. And if you want at that point, I'm just going to set this to be 31st of December. But you can pick any time. It's probably good to put it sometime into December or January just because. Actually, why don't we do it like that? Let's put it to the end of January just to be safe, because I think we often make the deadline for the final exercise so that you can still turn it in after the start of the new year. So I'm putting it 31st of January 2023 for the expiration date. All right, then we got to set the scopes. So we need to kind of define for this personal access token, what level of access will you have? And I think I'm just going to double check that I get this right. So it should be repo, it should be admin repo hook, and it should be delete repo. So those three things. So let's check repo. We'll get the whole thing there. Then there's admin repo hook. So that's most of the way down there. And I think then there's delete repo as well. So it's those three that you should have. So repo access will allow you to basically have full access to your repositories using this token, which means you can check and see what's changed and access things like that. You'll have write and read access to the repository, and you'll also have the possibility that your token can be used to delete a repository. Probably won't do that, but it's okay to have that as the scope. Once you have selected those three things, you can click the Generate Token button down at the bottom. And what this is going to do is create this sort of long string of characters here. You're going to want to copy this. And so I'm going to click the little, overlapping squares thing here to copy it to the clipboard. And then I'm actually going to go to my Jupyter Lab instance on the CSC notebooks. So that's here. And I'm going to go File, New, and File, New, and Text File is what I'm going to choose here. So File, New, Text File, and then I'm just going to paste this thing here. So this is basically just my way to have my personal access token available to me, because in a moment when we start trying to do things like copy your exercise 1 repository to the CSC notebooks, you're going to need that personal access token to do that. So this is just putting it someplace handy. The thing is, as it tells you here, make sure you copy your personal access token now. You won't be able to see it again. So once I close this page, if I click, for instance, on personal access tokens here, I can no longer see the actual content of the name of this token. I can only see that it exists as a token that I can use. So when I click personal access tokens over here, I can now see I have something called Geo-Python 2022, but I can't see the actual value of the token. If this happens to you and you're like, oh no, I forgot it, I lost it, whatever, you can just delete it and generate a new one. So it's like a disposable process. We're going to show you a way in which you can basically cache the token so that on the CSC notebooks we'll enter it one time, or maybe once or twice, but then it will store it in the future so that you don't have to type it in ever again. But if there's some point where it stops working, you can always make a new token, and you can find the instructions on the course page for how to create this personal access token. So don't fret. I have one here, for instance, my kind of normal token I use, which allows me to basically do anything on GitHub within the scope of my permissions for modifying files. It's a little bit different than this Geo-Python 2022. So was everyone able to generate their personal access token and put it into a text file just to have it accessible? Again, you can make a new one if you need to. So we've generated our token, we've copied it, put it into a text file, and now there we go. We're going to go and find your exercise number 1 repository on GitHub, and we're going to copy it to the CSC notebooks. So it's going to be somewhere in github.com/geopython-2022. For me, it says exercise-1-Dave Whip, so it should be like exercise-1-your username.git. Probably if you just go to github.com, I would guess for most of you, when you go to the to your sort of starting page, maybe even on the left side, it just lists this exercise number 1 repository there. I'm not sure, because I have a whole bunch of stuff I have access to on GitHub, whether I would see it, but if you go to github.com/geopython-2022, you would probably also see that it's in there. Now, of course, for me, I can see all of your repositories, so like I'll see lots of other things here. But you should hopefully, I think, only be able to see maybe your own repository if you go to Geo-Python-2022 for GitHub, and then you can find it that way. There's a couple different ways you can get there, but for me, it's going to be something called exercise-1-Dave Whip is my personal copy of exercise number 1. So that's what you're trying to find on GitHub, is your personal copy of the first exercise. So it would look just like this, except for it should have your GitHub username at the end, not mine. And yeah, if you're having issues with that, maybe let me know. Otherwise, you can find also the same instructions on the course webpage. But once you've gotten to your personal copy of the exercise, the thing you can do here is in code, if you click the button there, you can then click this thing over to the right of the name of the repository to copy its location. So I'm going to click the little overlapping squares that copies the location of my exercise number 1. Again, I can see this as my personal copy because it has my GitHub username in it. And and then I can go back here. So I've copied the name of my exercise number 1 repository, and now we want to clone that exercise. So back in the CSC notebooks, we have things here. So you should hopefully have your text file with your GitHub personal access token in it. And if I open up the file browser here, I'm just going to go click on the base file directory to take me back to my kind of starting, kind of home directory. And inside here, I've got the My Work folder. Double click on that. And I'm going to make a new folder in here. And I'll call this Exercises. So just click the new folder button, type in the name Exercises. Again, this is inside the My Work directory, which is important because if we don't store things inside the My Work directory, then they will disappear every time you sort of open a new notebook in the CSC notebooks system. So I'm going to double click on Exercises so that I can see I'm in My Work/Exercises. Is there anybody who's not in the My Work Exercises directory at this point? Yeah. Is it?
Just going too fast.
Yeah, okay, sorry. So let me, okay, so let's just maybe go with show of hands, anybody who was not able to create a personal access token. So yes, this personal access token now exists. You, sorry, hopefully inside your My Work directory, you've been able to click the button here to create a new folder called Exercises, and you should double click on that so that you're inside the Exercises directory. It's not going to be the end of the world if you clone this exercise number 1 someplace other than the Exercises directory, but of course, keeping things organized, it would be a logical place to have it. So now we are at the step where if you're inside the Exercises directory, you should see My Work/Exercises. There's nothing in it. We're going to click on the Git plugin here, and now it's time to click the Clone a Repository button. So when I click that, I again get this prompt that says like, okay, well, what do you want to clone? And that's where you want to take this name of your exercise number 1. So if I just go back here again to my exercise number 1, I want to copy the name of the location of where this is from the code button, and then I can paste that inside here. What's going to happen is that this is a private repository for your personal copy, so most likely when you click the clone button, instead of just being able to copy it like it was able to do earlier for our notebooks, you're going to be prompted for some information. It says, okay, maybe you can do this, but you're going to have to tell me who you are, because GitHub basically needs to check and say, do you have permission to copy this? And so in here, we're going to put in your GitHub username. So that's going to vary person to person, of course. And then we're going to need the personal access token, which unfortunately maybe should have copied first because I think I can't access it right now. So I clicked off to the side here. It tells me failed to clone. So we need to have access to this personal access token in addition to the thing that we're trying to copy here. So I'm going to have to figure out that maybe this is going to be a little bit tricky to do inside the same window. So again, when I click here and I click clone a repository, if I click off to the back here, then I can't see my personal access token. So I think you may have to either have a copy of it perhaps locally as a text file, or you can type in the name of your repository and just keep a copy of the personal access token here. So I'm going to select my personal access token and copy that first. Again, I'll click here on the Git button and then clone a repository, and I'm just going to have to type this in because I can't have two things copied at the same time. So sorry, a little bit clumsy to do it this way, but github.com/Geo-Python Python 2022/exercise-1-Dave whip.git. That should be the name of the exercise. So yeah, I mean, if you've got a text editor on your computer and you just want to put the personal access token in your text editor on your computer, the problem is that when you click off to the side of this thing, for instance, to copy the personal access token, once you start the clone process, then it tells you that it failed to clone. So I've typed the name of the repository in. I'm going to hit clone, and again, it asks me, okay, fine, I found that there is a repository there, but you have to tell me who you are. So I'll put my GitHub username there, and then I'm going to paste in my personal access token here. So sorry about the kind of clumsy way of doing this. If it's helpful, here's the sort of GitHub page. You can see the name of what you would have to type in here when you go to copy the location to clone. And then I just copied and pasted my personal access token. I suppose you could also type your personal access token in if you wanted to, but of course that's a long string of characters, and there's a good chance you'll make a mistake doing that. So, but yeah, are you more or less able to do this? Any major problems? Okay. So I'm going to click OK on my copy that I'm trying to clone, and if you're lucky like I was, you'll see that now I have my exercise-1 Dave Whip repository that has been copied from GitHub locally to my computer on the CSC Notebooks system. And inside there, if I double click on that, for example, I see my readme.md file. I haven't done my homework, so I don't have a notebook file in there. I have only the readme file that describes what I should do. But I can see if I double click on that, for instance, the information that's in that readme file that describes what to do for exercise number 1. So that's good. I've made the copy. My personal access token has worked because otherwise I would not be able to access these files because it is a private repository. So it seems like the personal access token experience has so far been a success. So that's good. Was anyone not able to copy their exercise number 1? Okay. So if you're having problems with copying exercise number 1, maybe the thing to do at this point would be to just kind of follow along for the rest of the lesson, and then we can talk after class because I'm concerned about the time. And there's a few other things we should at least see so that you guys can be able to work on exercise number 2. So we've cloned the repository. Again, the instructions for how for how to do this are all on the course page. So if you're not able to do it now, don't worry. The instructions on the course page are fairly detailed and should help explain how to do this. We put in our credentials and things like that. And now what you would notice if you're in your notebook is if you click on the Git plugin and if you double click first on the folder containing your exercise, so if I double click on my exercise number 1 and then click on the Git folder, now things look a little bit differently. Now it's not telling me to clone a repository or to do something different, but instead it tells me, oh, okay, exercise 1 Dave Whip is a repository. I'm currently in the main branch. That should be the case for you as well. And then there's some things here about changes that have been made, and well, there haven't been any changes made yet. So the only thing it shows is that there's a checkpoint file for the README, which you don't need to worry about for the moment. So inside this directory, I've opened up the readme.md file. If I scroll down to the bottom of it, I could say add something here like here is a change, and I just put a couple number signs in front of this because this will make a heading called here is a change, and then I could say yay. So I've now made a modification to my README file, and if I save this, now it pops up here as saying, hey, something in the repository has changed. So inside this Git plugin, it recognizes that a file that was part of the set of files that were being tracked earlier, those files that were part of the repository, one of them has changed, and it's just indicating to me that it's aware that there has been a change. Nothing has been recorded yet, but it's just aware that there has been a change. So this you could do yourself if you just want to add something to the end of the readme.md file and then save it. You'll see it pops up as being ready to have this change be saved. And when I put the mouse cursor over the name of the file, you can see there's a few different things that are here. So there's an option to open this file. There's an option to diff the file. So if I want to see what changed, I could click that button. There's a discard changes option. So if I wanted to go back, I could. But what we want to click in this case is the plus to indicate we want to stage this change. This is basically adding the file to the list of files that would be saved when we make a commit. So I click the plus button, and now my readme.md file jumps from changed into the staged area, meaning that the next time I commit my changes, this file will be part of those changes that will be recorded. It has not yet saved the changes to the file in Git. It's only now been made aware that the next time we do commit the changes, that this file will be part of that commit. So now if I scroll down just a little bit, I want to make sure I'm not missing anything important in the instructions here. But effectively at this point now, because I have a file that's in this sort of staged area, meaning that I've added the changes to the list of things that would be saved if I make a commit, you can also see the red box that pops up here around this summary. And so this is where we can actually put in a message that says what we changed, and then we'll hit the button to actually save the changes that have been made. So in here, if I put in my summary, this is basically where you can add a message to tell yourself what was changed when you modified the file. So I could say, for instance, added heading to show my Python excitement, whatever. This message is basically just a description for you and for other people who might look at the Git repository to tell you what was changed. Typically, what you would do is put something like, finished problem 1, and then you could have that message that you put in there. This is a short summary. Most of the time, that's the only thing I write, but if you wanted to, you could have detailed description underneath that. And if I scroll down a little bit, then I can see the commit button. And so now I have a file that's in the staged area. So this is a file that I've added saying, yes, I want to save these changes. I have a message here that says what I've changed, and I can click the commit button, and then I get prompted for some information here. The reason for this is that Git keeps track of who makes changes whenever you save a file. So you can put in whatever you would like here. But I would suggest putting in your actual name and email address. This goes into the Git log, so it's like the log of all the changes that have been made to the file. So I'm just going to put in my information here. I should only have to do this once, and I'll hit OK. And then when I do that, I get the thing popping up saying it's committing the changes, and then the green committed changes. And now you'll notice that there's nothing anymore in the changed or staged area, but instead I've now made a change that has actually been saved in the history of the changes to this set of files. And if I click on the history button, for example, I can see, for instance, the change that was made 23 seconds ago, which is that I added this heading to show my Python excitement. And before that, there was this initial commit. And those are the only changes that have been made to these files in their history, or at least as far as Git goes. If you're paying attention, you might have also noticed that there's this little orange circle that then pops up next to the icon that looks like a cloud with an arrow pointing up. And that is to say that we have committed the changes locally on the CSC notebooks, but we haven't actually saved them to GitHub yet. So you kind of get the idea that there's multiple steps in here. Sometimes you don't want to push the changes to GitHub until you're finished with the exercise, but you want to maybe save them as you're working. So we've done this. We've been prompted. We can see the changes we made, and we can also, for instance, here avoid having to type in our token every time by using a little trick that's in here. And I think, well, if you copy and paste this from the course webpage down here in the section beneath where it talks about the history of the files, there's this git config command that will store your Git credentials in a file so that you don't have to enter them over and over again. I would say maybe this is something you can do during the exercise practice sessions, or you can try and follow the instructions on the course page. I will show you how this works, but in the interest of time, I'm not going to maybe make sure that everybody can do it right now, just because we're behind a bit. But if I was to open up a new terminal, this is basically a place where I can enter different commands, and if I paste in this git command I just copied, and run it, nothing really happens, but we'll see how this works in just a second, because I think the next time that I enter my credentials, like my personal access token, should be the last time that I have to do that. Otherwise, you can always enter them every time you save your changes. So yeah, let's push our changes to GitHub at this point, and then we can continue from there. So one good habit to get into before you save any of your changes, so we are back here in our README file, for example, is there's a button up here to pull the latest changes. So it's probably not going to affect you working on your exercises, but it's not a bad idea that if you happen to have changed something on github.com yourself, that you can click the button to pull your changes first. It's going to, again, ask you for your login credentials. So before I do this, I'm going to copy my personal access token, click the cloud with the down arrow button, put in my username and my personal access token, and then it's going to pull. All this does is just checks to make sure that there's nothing that's changed on github.com before I push my changes to GitHub. The reason for pulling first is that if you're going to have this problem of possible merge issues, if you push your changes to GitHub and things have been changed there and on the CSC notebooks, you may end up with a merge issue. So I have pulled my changes down. It asked me for my login credentials. If I click the pull changes button again, I'm not being asked for my credentials, and that's because of the command that I copied and pasted a minute ago, and I'm sorry to have kind of rushed through that. But it should also mean that when I push my changes, it doesn't ask me for any information. So I click this icon to push my changes. Successfully pushed is what it says. You'll may have to enter your login information, but you should see hopefully the same thing. And if I go to my exercise number 1 and just refresh the page, I now see that my change of added my heading to show my Python excitement, the change I made locally on the CSC notebooks has been pushed to GitHub. So I've been able to copy things down from GitHub, modify my files, and push them back up to my GitHub page, which means now that one of the course assistants could grade my exercise, for example, because my changes are saved in GitHub where they would have access to be able to see them. So that, I think, is the essence of everything we're doing with Git. There's also some instructions about how to use Git from a terminal. I'm not going to go through those, especially now, because I'm pretty sure that your sort of ability to absorb information is nearly completely reached. So I'll just show you a couple other things about this lesson number 2. There's some information about using the classroom for GitHub. You could just read through this. It's not really that important to understand how things are working in the course. There's also a good coding practice about describing your code, which is basically about how to add comments to your code and different kinds of comments, maybe why you should add them, and things like that. So again, you can scroll through and read this over, give some examples of different styles of comments you can add in a Jupyter notebook. Then there's the thing about why are we working in pairs. So perhaps this comes as a bit of a surprise to you, but yes, we're going to be working in pairs on the exercises in the course. This is largely just so that you have someone to talk to when you're working on the exercises, but it turns out that there is a programming practice called pair programming, where 2 people sit in front of one computer, and the idea with that is that one person is the driver and the other person is the navigator. So the driver is the one with the hands on the keyboard who's typing things in. The navigator is looking over that person's shoulder and catching all the sort of little mistakes that happen as we're typing things in. So little typos and other things, just kind of like reviewing what that person's typing in as they're working. And the idea with this is that you make fewer mistakes when you're writing your code, but also both people are learning things simultaneously. Different things perhaps, but at the same time. So we will send information about who your partner would be for the pair programming, and we'll try to put that information, I think, on Slack at some point by maybe tomorrow morning, so that you know who the pairs are. If for some reason you feel like your sort of life situation prevents you from being able to easily work in pairs with someone, let us know in Slack. We do know, like, some people who, for instance, are working may have a difficult time being able to meet up with a partner to work in a pair. But we would like for people to do this, and that then what it means for us is that we're only going to grade the exercise of the driver each week. And so you as a pair would turn in one exercise between the 2 of you, and we'll see how that goes. In the past, I think students have largely enjoyed being able to work together with someone. We try as best we can to pair up brand new programmers with people who maybe have a little bit of experience as well. So that's that. And in the remaining, I realize I'm going to take it right to 12 o'clock today, so sorry for that. But in the remaining minute or 2 here, I just want to show you quickly what exercise 2 includes so that you know what's going on. Again, sorry about going a little bit long on the time, but we had the CSC notebook stuff that should have happened last week that couldn't, and that set us behind from the start. Exercise number 2, no surprise, is about lists and indices. So that's the kind of scope of the exercise. We are giving you a starter notebook here, so please make all of your changes inside this notebook. When you make your personal copy, you'll be able to copy it to the CSC Notebooks platform and open it up there. And please make all of your changes inside the notebook. There's 3 problems. So the first one, problem 0, is basically just about cloning the exercise, and so that's some practice to do that. But then there's a problem here about some of these meteorological stations and when they became active for the first time. So you'll make a list containing the values from this table, or actually 2 lists with the values from the table. And then you'll see that there are some code cells in here that will basically, you'll be told to run to check and see whether you have entered the values to the list correctly. So like this has a little assertion test in here that checks to make sure that station names has 5 values in it. So this can kind of help you out in making sure that you're on the right track for how you're working on the exercise with these, they're sort of like test cells in the notebook. But what you'll see is that there'll be things in here like these raise not implemented error with a heading above it that says your code here. So basically, yeah, you want to delete this and put in your answers here. That's the kind of idea with this notebook that we're providing for you. Then in part 2, you're going to add a few extra stations to your lists, and then you'll sort the lists, and then there's an open spot where you can answer how things worked in the exercise, and there's an optional activity if you'd like to figure out how to use a function called zip in Python, and you can do that. Problem 2 is about looking at temperature data from the Malmi airport, and what you want to do is be able to print out some text that looks like the average temperature in Helsinki in March is minus 1.0. So you're given instructions here about how to fill in some different values there, and then again there's some tests that allow you to check and see if you've done things correctly. And at the end you have some practice using this markdown language, which is what's used to make this kind of descriptive texts in Jupyter notebooks. So for example, this is all markdown text here. So there's kind of like shorthand ways to make headings and to make links and bold text and all of that. So you'll get some practice making some examples of things in Markdown. So answering questions about this week's exercise, and then inserting just for fun a picture of some animal you like into your exercise, and then saving that and putting it on GitHub. And that's it for exercise number 2. So apologies again for going really right to the absolute limit. In fact, 1 minute over. I should stop now. But if you have any questions, feel free to come down, and I'll be here for a few minutes while I get cleaned up. Otherwise, see you Thursday or Friday in the exercise help sessions, or back here on Wednesday next week.